Dear and beloved students, welcome back to our Climate Change Basics 4. To sum up of the first three basic classes, we tried to understand the definitions of climate change, variability, global processes. Then in the second class, we tried to impress upon, to learn on what are the impacts of climate change on different aspects, including agriculture and how to counter them. Now, in the Climate Change Basics 4 class, we are going to learn 4 subtopics. 1. Tackling climate change. 2. Climate neutral. 3. Computation of impacts of climate change and variability. And the last and fourth one is basic models for climate change and variability and impacts of climate change and variability. Good. Before we go into the class, I would like to share with you a small, very interesting aspects. A lesson for a patience, in my opinion. One day, Gautam Buddha asked one of his disciples to get some water for him to drink from a pool nearby. When the disciple reached the pool, he found that its water has been muddied by an elephant that had waded through. He was going to another source of water. Then Gautam Buddha called him back. The disciple explained that the water in the pool was muddy and that he was going to a stream further up. Gautam Buddha commanded him, no need. The water from the pool itself will do for him. The disciple was shocked. Still, obeying the orders of Gautam Buddha, the disciple went back to the pool and found that the mud had settled down and the water was now clear and very sparkling. So, what it means? Never do anything in haste. This was the message Buddha advised to his disciple. Therefore, the inference is when you encounter difficulties or turbulence, whatever it may be, wait for the things to settle down. Like the mud in the pool. Therefore, cultivate patience. You will grow up in the career, both at personal and official levels. Now, coming back to our class, very interesting. Climate Change Basics 4. 1. Tackling climate change. How you can tackle the climate change? Very interesting. It is through education, it is through research, it is through extension, it is through outreach. Innumerable ways you can tackle the climate change. Number 1. Improved crop management practices, both traditional and new technologies, standardization of crop models, changes in agronomic practices, for example, adjustment of planting dates or sowing windows, improvement of carbon sequestration, monitoring of crop development and growth, together with climate information, development of water conservation strategies, planting of shelter wells. In addition to this, implementation of sustainable agriculture and forestry practices, development of innovative new technologies like climate forecasting alongside traditional methods, that is intercropping, mulching, crop rotations, mixed cropping, whatnot. Any agronomic practices you can go. Similarly, response farming at the local community will do excellent. A use of shorter crop rotations, very good for arid, semi-ready areas. Increase the application of integrated pest management, prevention of overgrazing of grasslands, allocation of some summer fallow areas, introduction of reduced tillage and intensity reduction for tillage, maybe again summer fallow areas, improved manure management or fertilizer management, finally improve the inorganic nutrient management with suitable fertilizers. So these are all the measures what you may have studied in Agro 102, or you are going to study all these things in several courses of crop production. So basically, to go for tackling the climate change, any aspects what we discussed, what I have enumerated, a combination of one or two or more would help to tackle the climate change. Now, let us go to the second aspects of the today's basics 4 is climate neutral. As I said in the beginning, climate change is the defining issue of the 21st century. Of course, the issue stays until it is solved. Climate neutral, which we are discussing, is defined as a way which produces no net greenhouse gases emissions. Again I will define, again I read, again I explain. It is defined as a way which produces no net greenhouse gas emission. As I said half minute back, climate change is the defining issue of 21st century. This climate change issue stays until it is solved. One of the several options is climate neutral. Again, for your benefit, I would like to define, I would like to read, I would like to explain the definition of climate neutral. It is a way which produces no net greenhouse gases emissions. What exactly does it mean? Today, what had happened with the land use change? Good. Today, what had happened with reference to greenhouse gases emissions? Okay. Today, what had happened so far with reference to several others anthropogenic effects? No problem. At least from now, we should not and must not involve or try to enhance the greenhouse effect and global warming. Of course, this could be achieved. It is usually large number of scientists from meteorology, climatology, astrophysics, whatnot, innumerable sciences related to climate change have stressed upon this word climate neutral, and they all together advised 2 points as far as climate neutral achieving is concerned. Number 1 is reducing the greenhouse gas emissions as much as possible. Second one they advised is using carbon offsets to neutralize the remaining emissions. Using the carbon offsets, sinks of carbon to neutralize the remaining emissions, only to achieve the climate neutral. So, in this class so far we discussed tackling climate change, climate neutral. Then now we go to computation of impacts of climate change and variability. What is meant by computation? There is a procedure followed for computation of climate change impacts and variability of climate. Few steps that usually followed or suggested by scientists are: first, estimate the climate change impact from the available global and regional data. First point. Then collate that information on climate with agriculture, policy, trade, social and economic factors. Then define a series of forecast scenarios and also define a series of response envelopes within which the current production system can contribute to function. Then go to make qualitative and semi-quantitative estimates of the types of impacts that might occur. Finally, find out whether the existing production system can respond to the projected future scenarios found. So here, in a very simple way, I would like to explain computation of impacts of climate change and variability is very essential for research. We must and should do this exercise. Just by the 5 steps which I had explained to you, to sum up these 5 steps, first obtain the global and regional data. Collate that information to the existing situations. Define a series of forecasts. Define some response envelopes. Then make qualitative and semi-quantitative estimates. Finally, find out whether the existing systems are responding or we wanted the new system or modified system. This is simple. So this is how we can do computation of impacts of climate change and variability. Now, the last and final, the fourth one as a subtopic for today's class is basic models for computation and evaluation of climate change and variability. Basic models. Earlier, we discussed the procedure 1 minute back. Now, what are the basic models? The basic models are conceptual or theoretical concepts, small scale quantitative simulation models, system scale quantitative modeling. I repeat once again, there are innumerable concepts, theoretical, conceptual, innumerable simulation models at the small level, micro level, meso level, macro level, system level, all these things. However, since this is a basic course, we just try to understand in the next 1 or 2 minutes to follow what are the basic models. Just you should understand. Usually we go for a top-down evaluation of climate change impacts. Okay, top-down means from top to the bottom level, so that the research can be easily conducted and we can find out the results also for climate change impacts. If any negative impacts are there, how to do it. So, 1.5 minutes back, we tried to understand computation, how you can computation. Then, once you have got computation, what are the basic models that you can do it. Now, the first one, as I said a minute back, conceptual or theoretical concepts. The concepts of theoretical nature usually assess how climate change might influence crop, how climate change might influence animals, how climate change might influence forestry, etc. So concept theoretically, for example, in a region or in an area, a specific amount of rainfall is predicted. In that region, can this crop can be grown successfully, which gives economic yield or profit to the farmer. So theoretically, we assess qualitatively. Theoretically, we assess qualitatively the rainfall predicted and the crop yield. That's what we call it as the conceptual or theoretical concepts. Now, the remaining two are simulation models. Simulation means, replication or mimicry. Suppose Himalayas are there, everybody cannot afford Everybody may not be in a position to go to Himalayas. However, in a picture, in a photo, okay, Himalayas look like this. That's what we call it as the modeling, the model of Himalayas. So similarly, computer-based models are there for climate change and climate variability impacts. Simulation means mimicry. Okay, right. Small scale, system scale are there. Now, what is small scale quantitative simulation model? Simulation means you use computer, mimic the whole system at the small scale level. For example, statistical and mechanistic models are there. These are used to predict the crop responses to climate change in a relatively small scale areas, like a small district of Andhra Pradesh, for instance. Now, an example is in a particular district of Andhra Pradesh or India, how the response is coming from the ground top to changes in the air temperature during flowering. You wanted to know? You go for small scale quantitative simulation model. Similarly, the third one, system scale quantitative modeling. Now, here also we use statistics or mechanistic or empirical models we use here. It is only to predict crop responses to climate change in larger areas. Say for example, a state of Andhra Pradesh with 13 districts. An example is response of rice-based cropping systems to weather and climate change. Now, so this is what I would like to discuss with you in the climate change basics 4. Thanking you very much. Now, I once again request, do not forget to share the content with your friends and classmates. To share the knowledge, also like, comment, subscribe for more educative and informative videos. Thanking you very much. May God bless you.